Assalamu alaikum and hello everyone. We are Team ZenCoders. My name is Muhammad Tayyab Khan and along with my group members Muhammad Ayaan Khan and Vishal Kumar. Today we are presenting our C programming project, a currency converter. This is not just a simple tool. We designed it from the ground up to be a software tool for seamless currency conversions, focusing on robust, scalable, and professional programming principles. Let's start with a brief overview of the project. Our project main aim was to develop a robust and scalable currency converter in C. The development team, ZenCoders, collaborated on this. A key part of our design, which we will discuss a lot, is that converter is user friendly and reads all of its currency rates from an external data file, not from the code itself. Here is a look at what we will be covering in this presentation. We will start with the project introduction and objectives. Then we will cover the technical design and core features. After that, we will do a detailed code analysis, including a line-by-line walkthrough. We will then show the program flowchart, discuss future improvements, and end with a conclusion. So let's begin with the introduction. The main challenge we identified is that existing or basic converters are often hard coded. This means they lack scalability and can crash if the user gives bad input. Our primary objective was to develop a robust, scalable, and user friendly console application in C. To achieve this, we use a data driven approach. All currency data is sourced from an external file called rate.txt. This is the most important part of our design, as it enables easy updates without ever changing or recompiling the core C code. Now let's get into the technical design and the features we built. Our program has four core features. External file handling. It reads from a file to support over 180 currencies dynamically. Intuitive user interface. A simple console menu with three options: convert, list all, or exit. Robust input validation. We build checks to prevent crashes. For example, if a user types ABC instead of a number. Efficient conversion logic. This is key. We use a single base currency for all conversions. So to convert PKR to euros, we first convert PKR to USD and then that USD amount to euros. This one formula simplifies the entire program. This brings us to the code implementation. So how does it work? We use a C struct called currency to organize our data. It's a blueprint for the code, name, and rate. We use a file reading mechanism, specifically fopen and fscanf, to read the rate.txt file line by line when the program starts. We use the two-step conversion process we just mentioned, the base USD logic, and the formula is final amount equals base amount upon from rate into to rate. Now let's go to the live code walkthrough.
Assalamu alaikum Assalamu alaikum everyone. So now I will be introducing and explaining my part of the project, which is the actual C code behind our currency converter. From reading the data and from a file all the way to finding the right currency rate. So let's begin. Slide one, which is the include and extract definition. We start with three header files, stdio.h, which let us print messages and take input. Then we have string h, which give us tool for handling text like comparing or measuring strings. Then we have the ctype.h, which is a character function such as to upper, which we will use later. Then come to our structure name currency. Think of it like a small box that will store our one currency information. It is short full name and how much it worth in US dollar. Then we have the slide 2, which is the main function and file opening. Every C program starts from main. Here we can make an array that can hold up to 200 currencies and a counter that begins at 0. Then we create a file pointer and open rate.txt in read mode. The file contains all the currency data our program will use for conversation. Then we have the slide 3, which is the file error and handling. Now we can make sure the file actually open. If it didn't open, then we use fopen, which gives us the null. So if this if block prints a clear error message, pauses the screen and safely ends the program. That way our converter never crashes if the file is missing. Then we have the slide 4, which is the file parsing and file parsing loop, which is the F scanner. This loop reads every line from the file one by one. The pattern, percentage, square bracket, carry, and the comma, which means read until the comma. So we can pick up the code, the name, and then the rate number. Each line fills one position in our currency array, and currency underscore count keeps track of how many we loaded. If it is ever reached 200, we stop and shows a small warning. Finally, we close the file. Then we have the slide 5, which is the main menu and output. After loading the data, we show our main menu. The variable choice will store the user option. We use an infinite while one loop, so the menu keeps appearing until the user exits. The main menu itself is printing with 9 borders and tells how many currencies were successfully loaded. Then we have the slide 6, which is the menu input and scanner worksheet. Now we take the user choice using scanners, but sometimes the user types letters instead of numbers, and that causes the classic scanner bug. So this code checks if the input works. If it didn't, we clean the keyboard buffer, shows an error message, and restart the loop. If everything is working fine, we move into the switch statement that control our three menu options. Then we have the slide 7, which is the case 1 setup and amount input. Case 1 handles the conversation feature. We create variable for the currency code, their uppercase version, the amount, and the small variable for again to let the user repeat conversion. Inside another while one loop, the program asks for an amount to convert. Just like before, if the input isn't a valid number, we create it and ask again. This keeps our conversion strong and user friendly. Then we have the slide 8, which is the string input and swapper. Now we take the two inputs, the prompt and two currency codes. Maybe the user type them in lowercase or mid-case. To make things easy, we loop to each character and change it to uppercase using swapper. The way whether the user writes PKR in small case or PKR in capital case, the program will understand it perfectly. Then we have this slide 9, which is the search algorithm. Here comes the searching part. We set up both rates to 0 and assume we haven't found anything yet. Then we loop through the whole list of currencies. Whenever a match is found using StarChem, we save its rate and mark it as found. By the end of this loop, we will have both rates, the only we are converting from and the one we are converting into. These values will be used for the actual calculation in the next section.
So my name is Vishal Kumar. This is a project of CCP. Name is currency converter. So here I am discussing about slide 10, which is case 1 math and result output. In this, here we can see the initialize our research variables. We set the rates to 0.0 and our found flags to 0, which means false. We use a simple linear search. We loop from I equals to 0 up to currency count. Inside the loop, we use string compare from string.h to compare the users from upper string with the code from our currencies I struct. String returns 0 for a perfect match. If it's a match, we store the rate to USD and set from pound to 1 or TRU. Third one is we do the same thing for the upper code. The loop continues until we have checked every currency. And in this, after the search a loop, we check our flags. And if either from pound to found is still 0, it means the user entered an invalid code. So we print an error. Otherwise, if both were found, we execute our base USD math. We calculate base amounts by dividing the user's amount by from the rate. This converts the source amount to its equivalent in USD. Then we calculate the final amount by multiplying that base amount, the USD value, by to the rate. Finally, we print f the result using %2f to format the output to two decimal places. In this, and here is the actual output from the code we just saw. You can saw a user converts 5000 PKR to euro. This code handles a lowercase PKR and euro and prints the correct result. Then they choose Y to go again and convert 100 USD to PKR, showing the reverse calculation also works perfectly. Finally, the tag and to return to the menu. Then case 2 is about for listing all the currencies. We print a header, then loop from I equal to 0 to currency count. And inside the loop, we print the code and the name. The format %10 as means left justify the string and paired it with spaces to be 10 characters wide. This makes our list neat and aligned. At the end, we use getchar. This is C trick to pause the screen. The first getchar consumes the new line left over from the main menu scan up, and the second one waits for the user to press enter before continuing. In this, here is the output for list currencies. You can see the clean aligned columns produced by our %10s format specifier. This shows the user all 200 currencies that were loaded from the rates.txt file. So they know which codes they can use from USD all the way to SMW. Finally, case 3 is a clean exit. We print a thank you message and return 0. This terminates the main function and ends the program. 1. The default case catches any invalid numbers from the main menu like 4 or 5 and prints an error. Number 2. The while one loop the repeats and showing the main menu again. The final return 0 at the very end of the main function is the standard for a successful program exit. Here is a code of currency converter. Here you can see all of the code. Now we can go for output of this. So here is coming three options, three choices. Number 1 is convert a currency. Number 2 is list all available currencies. And number 3 is exit program. So we are going to pick a choice number 2. So here you can see the currency of many countries. Now we can pick. Any of them randomly, like Libyan dinar. So here is the code Libyan dinar. Okay. So this the code of Libyan dinar is LYD. Okay. So first we enter the amount which we are going to convert, like 20 20 USD dollars convert into LYD. Libyan dinar. So here you can see the conversion of USD into Libyan dinar. 20 USD is converted into 96 Libyan dinar. If we want to another conversion, so we can do much more. This concludes our line by line code walkthrough. We will now return to the main presentation. So let's back to our presentation. Our slide 12, its name is visual representation. So we have just completed a detailed line by line analysis on our C code. Now let's take a step back and look at the project's logic from a high level perspective using a flowchart. Here you can see a program flowchart of our currency converter. So on this slide, we can see a complete logical flow of the program. So first one is it begins at the start block. The first major operation is open currency file, which is our open rates.txt call. Second one is the program immediately hits a critical decision. Is file found? This is our if file null is equals to null safety check, and if no, the program flows to handle file error. And the end, this prevents the program from crashing if the file is missing. If yes, we enter the main data loading loop. More lines to read in file. As long as this is true, we read one line of data using our fscanf logic and load it into our struct array. When the loop is finished, we choose file and proceed to the main application. We display main menu and get users choice. The central watch choice diamond controls all three of our main features. Option 2, list, and option 3, exist. Exit are simple. List currencies just prints the data and loop back to the menu. Exit leads straight to the end block. Option 1, convert, is the most detailed. It moves to the second part of the flowchart. Here we get the amount, validate it, get up from and to codes and convert them to uppercase. The next crucial step is the codes valid and rates found. Diamond. This represents our search loop. If no, we display error and ask to convert again. If yes, we perform conversion using our base USD math, print conversion result, and then ask to convert again. The entire conversion loop repeats until the user enters, and this is our program of flowchart. So enhancement ideas. The flowchart shows how our programs work today. Now let's talk about the future and how we could make this project even better. We have identified the three major potential enhancements. Future improvements. And first, a graphical user interface (GUI), the full form of graphical user interface. The console is a function, but a GUI with drop-down menus would be far more user-friendly. It would also eliminate user error as they could only select valid currencies, not type in invalid one. We could use a C library like GTK plus or port of the logic to C++ and GT. Second, life extend rates. Our rate text while dot text while is static, meaning the rates are fixed. Our more advanced version would use the C library like libcur to make an API call to a live currency service. It would download the latest rates, probably as a JSON file every time the program starts. This would make our converts accurate to the minute. Finally, search functionality. Our list currencies feature works, but as you saw, we have over 180 currencies. It's a lot to scroll through. A search feature where the user could type Pak and the program would find Pakistani rupee would be a massive quality of life improvements. So wrap up everything up. Let's summarize the project. Conclusion. To conclude, this project was successful application of core C program of concept. We use struct and file I upon O to build a tool that is genuinely robust and scalable. We prove this by separating the program's logic, the C code, from its data, the rates.txt file, which is a key principle in professional software development. We didn't just meet the academic goals, we also learned how to handle practical real world problems like debugging scanf input buffer and designing an efficient algorithm like the base USD conversion. The project provides immense academic and practical value and serves as a strong foundation for the future. Okay. Thank you. On the behalf of all of us at ZenCoders, Mohammad Tayyab, Mohammad Ayaan, and myself, Vishal, I want to thank you for your time and attention. We would also like to thank you, our teacher, Sir Abdullah, for his guidance. We are now happy to answer any questions you might have.